This thing, this box over here, is called the coordinate plane. It's formed by the intersection of two number lines, the x-axis and the y-axis. X, Y. Okay, the x is the horizontal, the y is the vertical. You just have to know that. Here's a way to remember it. When you were in grade school, the first number line you learned was the horizontal one, right? Okay? And then eventually you got bigger and older, and you learned about, hey, there's this axis also, right? The vertical one. Okay? Well, look, the first one you learned, the second one you learned. What letter comes first in the alphabet, X or Y? The first one you learned X, the second one you learned Y. Okay, the origin, 0, 0, is the point where the axes intersect. There are 4 quadrants. We're going to label them. That's the first quadrant right there. We use a Roman numeral. Okay? Roman numeral 1. Okay? Now, that is where all real world graphs are. Okay, so when you're graphing anything like stock prices, gas prices, hours worked, sleep over time, any science experiment you ever did in grade school for science fair, your graph was in the first quadrant because that's the real world, positive, positive. You can't go back in time, you can't have negative data, okay? So that is the first quadrant. Then why, I don't know, we go backwards, counterclockwise, 1, 2, 3, 4. I'm not sure why mathematicians didn't go clockwise, but that's the way it is. But the most important one is 1. That's the real world. A point is represented on a graph using ordered pairs. An ordered pair is written in the form of x, comma, y, alphabetical order. So in other words, we always move left and right before we move up and down. The x-coordinate, let's try to abbreviate forward, represents the horizontal axis, which we've already talked about. And again, it shows you right and left. The y-coordinate represents the vertical, which is up-down placement of the point. Okay, 2, 3. So we're going to plot these. Use a different color. 2, 3. Remember, we go in alphabetical order, so we're going to go right 2, up 3, and put an A. That's in quadrant 1. 4, negative 1. 1, 2, 3, 4. Negative 1 means down. That's B. That's in quadrant 4. 0, 5. Kind of a tricky one. 0 means it doesn't move left or right. It just goes up straight. 1, 2, 3, 4, 5. That's C. 0, 5 is on the y-axis. It's a y-intercept. Okay, it's on the y-axis. Negative 2, positive 2 means go left 2, up 2. That's D. And that's in quadrant 2. Then we have negative 1, 0. Okay? It's on the y-axis. Like I said, x-axis. Let's see if you're paying attention. It's on the x-axis. It is an x-intercept. Again, I don't make mistakes. I just throw things out there to see if you're paying attention. Now, the only thing we don't have is we don't have anything in the third quadrant. So that would be something like -3, -7, left and down. An ordered pair, x, y, is a solution to an equation, such as y equals 2x plus 3. Okay? A set of ordered pairs is called a relation. The relation can be set in different ways. So if you have a table of values, that's a relation. How are the points related? Okay, input, output. So 2x plus 2. All we're going to do is plug these numbers in. So y equals 2 times, and you're just going to put -2 in each one of these. And then we're going to crunch the numbers. So 2 times -2 is -4. Plus 2 is -2. So that gives me the point -2, -2, which would be in the third quadrant. Okay? -2 times -2. I'm sorry, my bad. What am I doing? I'm just not paying attention. Whew, that was just silly of me. We're plugging in -2, -1, 0, 1, 2. Time for me to go home. Okay, so let's try this again. 2 times -1 is -2. Plus 2 is 0. That gives me the point -1, 0. Plug in 0. 2 times 0 is 0. Plus 2 is 2. So that's the point 0, 2. 2 times 1 plus 2 is 4. So that's 1, 4. And 2 times 2 is 4. Plus 2 is 6. So that's 2, 6. Now we're going to put those on our graph. So -2, -2 is down here. -1, 0 is right here. 0, 2, 1, 4, and 2, 6. 2, 6. And then there's our line. Now, over here, we have what's called mapping. It basically looks like a table, just written differently. So you just write the numbers again. It's just a different way of writing a relation. Mapping, ordered pairs, a table, all the same thing. Okay, algebraic. Example of relation, y equals x squared. It's going to look a little different. Numbers are going to do something different because we have this 2 here. We're squaring the number. So we're going to plug in -2, -1, 0, 1, 2, just like we did last time. Otherwise, I'm going to put the same number every time. That'd be silly. So, -2 squared is 4. -1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. Notice what we have here. We have the same numbers. Because a negative number squared and a positive number squared are the same thing. So, we have the ordered pairs -2, 4, -1, 1, 0, 0, 1, 1, and +2, 4. So when we place those, -1, 1, +1, 1, -2, 4, +2, 4, we have a parabola, which is a U, not a V. So make sure you try to put a little bit of curve in that. And then we're just going to write the same thing, mapping. Now, here's where the mapping is different. Before we didn't have any repeats. But we only have to write 0, 1, and 4 one time. And then we write -2, -1, 0, 1, 2. And now we draw arrows. Both of these give us 4. Both of these gave us 1. And that gave us 0. So instead of writing the ordered pairs like we did before, now we just write the repeats one time and draw arrows. Okay, so what's a function? Some relations may be called a function if each input x only gives you one output y. Okay, so there's the definition. Function 1 for 1. Okay? So, think about it this way. Here's how I like to describe it. If I plug 3 plus 4 in the calculator, what will I get? 7. But if I plug 3 plus 4 in the calculator and get 7, but then I do it again and check my work and I get -2, and then I do it again and get 15, and then I do it again and get 0, and I do it again and get -30,247, you'd probably say that my calculator is not what? My calculator is not what? Working. It's not functioning. You got the little hint there. It's not functioning, right? Because whatever I put in, I've been putting in 3 plus 4 one time, right? Each time. But I'm getting a different output every time. My calculator is not functioning. If I put in 3 plus 4, I should only get one output. Now, is there more than one way to get 7? Yeah. 6 plus 1, 5 plus 2, 8 minus 1, 2 times 3.5, 14 divided by 2. There's a lot of different ways to get that output of 7. But one input should give me one output. All right? So, 2 gives me 1, right? What does 3 give me? -2. It also gives me 1, correct? So I put 3 in. Do I know what I'm going to get? No. I might get 1. I might get -2. So that means no. Now, top of the page, talking about domain and range. Here's a quick way to remember it. X comes before Y. D comes before R. So domain is your X values. Range is your Y values. Okay? So for my domain, I'm just going to write one of these funky braces. That's what it's called. Parentheses, bracket, braces. I'm just going to write my X values. Now, I don't need to write the 3 one time because I don't need to repeat it. And yeah, my brace there looks like a 3, and I really think it's probably 3. So, 2 and 3. Now my range is my Y values. Okay? I only have to write the 1 one time because, again, I don't need to repeat myself. Kind of like mapping. You don't have to write 2, 3, 3, and 1, -2, 1. You can save yourself the trouble of repeats. Now, what's 1 going to give me? 2. Are there any other 1s here? No. What's 2 going to give me? What? 3. Are there any other 2s you're screwing me up? No. What's 3 going to give me? Any other 3s there? No. What's 4 going to give me? 4. Now, do I have multiple 4s? Yes. Is there more than one way to get 7 in the calculator? Yeah, that's okay. So this is a yes. And then we put our brace, and we start writing our X's. 1, 2, 3, 4. Now my range, I do not have to repeat, is 2, 3, 4. Okay, the first one. I gotta be careful here. And look at my X's. 1 gives me 4, but 1 also gives me -4, doesn't it? Okay, so because of that, it's a no. Well, and I'm going to go back now. Even though I list these up here, we don't have to list them. So I'm not going to make you, I just wanted you to see how they come to the repeats. But you don't have to do the domain range if it's not a function. Okay? So if it's not a function, you're done. Move on. Are there any repeats in my X? then I'm good to go. So I have 2, 4, 5, 6. Do I have any repeats of my y's? Yeah, the -1. So I only have to write it once. Do I have, no, this one's weird. Do I have any repeats of my x? So that's a no. We're done there. Do I have any repeats of my x? No. So my domain is just the -1, 3, 5, -2. And my range is 2, 4, -3. Do I have any repeats of my x? Huh? You do. It's not written twice, but doesn't 0 go here and here? Right? So, it's kind of like a hidden trick. Okay? So 0, I could write this. Couldn't I write this like this? -2, 3, 0, 2, 0, -4, right? Remember, mapping can have repeats. So the answer is no, so we don't have to do anything here. Okay, last thing on this section, the vertical line test. When determining if a relationship is represented as a graph as a function, you can use the vertical line test. Okay, if every vertical line you draw intersects the graph in only one place, then the graph is a function. If a vertical line intersects more than one place, then the graph is not a function. Now we're going to determine whether it is using the vertical line test, and let's just abbreviate the VLT. Okay, so vertical line. We're just going to draw a vertical line straight up and down. We're going to do a few of them. 1 point, 1 point, 1 point. Yes or no? I'm done. Now, is there a way I could draw the vertical line test and thought it was yes?
Yes, if you were not.
That's a horizontal line.
Oh.
If I drew a vertical line, can I draw a vertical line and only get 1 point? One point, right? But you have to do, that's why you do it more than once. 1 point, 1 point. Yes. Done. 1 point, 1 point, 1 point. Now, there's nothing drawn here, but, right? So that's a no. Even though it's not a drawn graph, it is data, so it's not a function.